In this video, we're going to talk about proportions. In our last video, we found out what a ratio was. It's just comparing a couple of things. A proportion is where we compare two ratios. So ratios are comparing two things, and we're comparing another two things to that, and we create a proportion. So for example, if we had a ratio that said 1 to 3, and we set an equation or an equal sign equal to another ratio, let's say it has to be equal to 1/3, so 2/6, then this would be a proportion. Two ratios equal, two equal ratios, okay? So if we compare, let's say, something that's 1 inch by 2 inches, like a tiny stamp of some kind, and we want to increase its size and keep it in proportion, keep it in the same ratio, but increase its size. Let's make it, let's make it 8 inches long, and then we would have to make the other side 16 inches long. So this is 1/2. Our two ratios are equal, and that's a proportion. We can also have other forms. We can do, this is our fraction form. We just did two of them. We could say the same ratio here. 1/3 is equal to 2/6. We could say that in word form as well, right? 1 to 3 equals 2 to 6. So there's our proportion. So set up another ratio, do the same thing but in colon form. 1 to 3 is equal to 2 to 6. So there's a proportion, equal ratios. So normally you'll see two different types of questions when you're dealing with proportions. But either way, you're always thinking about cross-multiplying. To solve proportions, we need to cross-multiply. Basically, anything that you want to talk about in dealing with proportions involves cross-multiplying. So here's an example of a complete the statement type question. Maybe they'll give you a proportion here. They'll do one of the cross-multiplications. They'll say A times D is equal to, and you have to fill in the next proportion, so you just cross multiply the other direction, and we would say BC. Okay, so cross multiplying. Let's try the next one. If you were given that 5A was one ratio, then what would the other one be? Well, it would be B times 4, or 4B. Okay, so you're always going the other way. Say in this example you were given 3x. What does that equal? Well, if you multiply this diagonally here, you're doing 7 times x plus y. So we're doing 7 times both x plus y. So we would have to distribute and then solve or simplify a little bit more here. We go 3x equals 7x, and then 7 times y, 7y. And then if we were to solve for x, we would have to get our x's together, but basically 7x plus 7y is what 3x equals. Okay, so that was completing the statement. A lot of times though, you'll see a missing part of a ratio, and you'll have to solve for that missing part, and we'll see that maybe this is a missing side of a shape a little bit later on, but let's just figure out how to solve this proportion. So we still cross multiply. We're doing 2 times x, and that equals the other cross multiplication, 5 times 10, which is 50. And then divide by 2, and x equals 25. So 25 over 10 is equal to 5 over 2. Well, that's true if you reduce that fraction. So they're equal ratios. Let's cross multiply this one. Again, we have to distribute, so we're doing 3 times x, that's 3x, plus 3 times 4, which is 12. And that equals the other direction. 4 times 2, which is 8. So to solve for x, we subtract 12 from both sides. That leaves 3x on the left side, negative 4 on the right side, and if we divide by 3, then x is negative 4/3. So it's possible to get a value like that for x, and just realize that if you were to substitute and find the real value there, you could do that as well. So equal ratios, negative 4/3 creates an equal ratio there. So like I said, we can use proportions to solve for missing sides, missing angles, whatever it is that's missing. We're going to use a triangle as an example here. So one way that we can do this, and there are many ways, this is one way that we can do this. If we're given the side values, if we're given 3 out of these 4 side values, so AB is 5, BD is 2, and AC is 10. See how we're missing one of these side values? You can set up ratios comparing the side, the left side, to a ratio comparing the right side. So if we compare, let's just say top to bottom, and it seriously does not matter. We could do bottom to top. This is just one way. But if we choose to do top to bottom on the left side, we have to set our ratio on the right side the same way, top to bottom. So we would start with 10 on top, and we're missing this length, so we'll use x as our variable for our missing length, and then we can solve for x. So 5x equals 20 is what we get when we cross multiply, and so x is 4. So the CE segment is 4. Fill it in. Alright, but we're asked to find a couple more things, AD and AE. Well, it's basically asking for the total length. So we got 5 and 2 together to create that total length. So A to D is a length of 7 units. On the right side we have 10 and 4, so together to create the whole segment from A to E we have 14 units. Alright, so there is an example of where we're missing side values. We'll see a few different varieties of problems in this video and the next. So here's another example of where we can set up kind of different styles of proportions. Let's see, it's usually based on the information you're given. So it's always nice to fill in the information you're given and try and figure out how you're going to solve for what's missing. So let's see, we're given AB, so now we're given a total length and we're missing this longer segment here. We're also given this total length from C to B, that's 24. And we're given the tiny segment up here, it's 4. Okay, so think about a proportion that we can set up. Let's think about our first ratio in our proportion. Since I'm given 2 values here, I'm given the total and the smaller segment, then I can set that up as a ratio. Let's compare that side. So I'm using the total on top over the smaller segment of the top on the bottom there. So I need to do the same thing if I set up a ratio comparing this these bottom 2 sections here. So we got the total, so I put the total on top, and I'm missing the smaller segment. So since I'm given the smaller segment here, I have to set up a ratio to find that smaller segment. I can't find this one yet. We'll find the bigger segments here in a sec. Let's just use what we know to solve what we don't know and build from there. So that's missing. Okay, so we got 12x when we cross multiply there. When we cross multiply here, we got 24 times 4. That's 20 times 4 is 80, and 4 times 4 is 16, so put them together, we got 96. So if we divide both sides by 12, then 12 goes into 96 8 times. 8 times 2 is 16, and we carry the 1, we get a 9, so that's 96. So CE, that's what we just solved for, right? The smaller side on the bottom. So CE is 8 units. Okay. Well, now if we want to solve for the bigger side, the bigger of the smaller segments here, then we would just subtract what we know from the total. 24 minus 8, that will give us 16, so that's that length. They add together to create 24. So what's 4 less than 12? That'll give us this segment. So that's 8, because 8 and 4 would give us a total of 12. So we can also set up other ratios, okay? So if we were given this larger of the smaller segments here and the total, then we would have to use that ratio and solve for what was missing over here. We can set up pretty much any kind of ratio as long as we compare it to corresponding parts on the other ratio. So we could say things like AB over the bigger one. What was it? DB. There it is. Because we know that ratio, that 8 to 12 ratio, would be equal to the ratio that we create over here. So the total, CB, over the bigger of the smaller segments, EB. Well, 24 over 16 is the same ratio, it's the same value as 12 over 8. And any of those, as long as we set them up that way to be the same ratio, we can solve for any of those missing pieces. All right, so those are proportions. We'll definitely practice a little bit more in some of the next videos here.